Hello students, today in this session we will discuss condensation reactions in carbonyl compounds. Condensation reactions, these are bimolecular reactions, and the first one is aldol condensation reaction. Students, as the name aldol, it clearly indicates it must be carried at first in aldehydes. Aldol condensation. Condensation reaction between two similar carbonyl compounds containing at least one alpha hydrogen atom in the presence of dilute NaOH. Students, that's the essential condition for aldol condensation. The carbonyl compound must have one alpha hydrogen atom. Let's try to proceed. Acetaldehyde CH3CHO. Students, carbon atom which is in link with functional group, we call it alpha carbon. We call it alpha carbon. It contains 3 hydrogen atoms. These are alpha hydrogen. Carbonyl compound having alpha hydrogen in dilute NaOH, aldol condensation reaction. Please try to understand. Both are same. What will happen? It is aldol condensation reaction. At first try to understand. It is bimolecular. In one of the carbonyl compound, carbonyl group participates. Carbonyl group participates. You know carbon oxygen, which is more electronegative? Oxygen. That is pi electron migrate to oxygen. When pi electron migrate to oxygen, it will have negative charge and carbonyl carbon will have positive charge. And in second, alpha hydrogen will participate. I open alpha carbon CH3, it is again CH3. What I say? In one carbonyl compound, carbonyl group participate, and in second, alpha hydrogen participates. This pi electron migrate to oxygen, definitely it will have negative charge. When it have negative charge, it will abstract alpha hydrogen from the other carbonyl compound. When it abstract alpha hydrogen atom, it changes to OH, and it is clear carbonyl carbon will have positive charge. When H positive migrate, alpha carbon will have negative charge. That is, bond formation takes place between these two carbonyl compounds. It means the plus sign changes to negative, means bond is formed. Please look here, what is the possible product? What happened at first? CH3, CH, carbonyl group participate, pi electron migrate to oxygen, it immediately abstract alpha hydrogen from the other carbonyl compound. CH3CHOH. It will have positive charge and the adjacent alpha carbon will have negative charge. That is bond formation. Means positive sign changes to negative. What is left, students? CH2, CH2. This compound contains two functional groups. One is aldehyde and second is alcohol. So we call it aldol. That is aldol. Aldol is a product when we treat aldehyde with dilute NaOH. It is aldol. Contain two functional groups, aldehyde and alcohol. It means, dear students, what happened here? You can directly say CH3, CH. Carbonyl group participate, pi electron migrate to oxygen. It abstract alpha hydrogen from the other carbonyl compound and changes to OH. What is left? CH2, CH2. But we call it aldol. That's easy reaction and important reaction. Friends, the product of the aldol upon heating undergo dehydration, that is eliminates water as the byproduct and leads to the formation of alpha beta unsaturated carbonyl compound. What will happen, students? This aldol upon heating undergo dehydration, eliminates water, means what happen? Alpha will lose H and beta will lose OH. Alpha carbon will lose a hydrogen atom and beta will lose OH. H and OH, water is eliminated as byproduct. When alpha lose H positive, definitely it will have negative charge. It lose OH, it will have positive charge. That is, bond formation takes place between alpha and beta. But remove one alpha hydrogen from alpha carbon. Dear students, what is left? Please look here. CH3, CH, double bond, CH, CH. That is alpha beta unsaturated carbonyl compound. That is, aldol undergo dehydration, eliminates water upon heating. Alpha carbon will lose H and beta will lose OH. You know, when elimination takes place, unsaturation comes, that is bond formation takes place. Double bond comes between alpha beta carbon, CH3CH double bond CH2. Now it is aldol condensation. It is clear. Carbonyl compound having alpha hydrogen. We treat it with dilute NaOH. It is aldol. Carried out in acetaldehyde. CH3CHOH CH2CHO. It is called aldol. This upon heating eliminates water as the byproduct. It means alpha will lose H and beta will lose OH. Loss of water, and there is double bond formation between alpha and beta carbon. It is aldol condensation reaction. The essential condition for aldol is there must be one alpha hydrogen atom, because the alpha hydrogen migration takes place in it. Students, that is acetone. Suppose the question is complete the reaction CH3COCH3 in the presence of dilute NaOH. It is a condition of aldol condensation. Treat carbonyl compound having alpha hydrogen in dilute NaOH. It has alpha hydrogen, alpha carbon. It is again alpha carbon, carbon atom adjacent to functional group. Definitely it will go aldol condensation reaction. You know it is bimolecular reaction. Students, it is clear what happened. In one carbonyl group participates and in adjacent alpha hydrogen participate. When pi electron migrate to oxygen, it abstract alpha hydrogen. That is, there is bond formation takes place between these two compounds. Dear students, what is formed? CH3, OH, CH3, bond formation, plus sign changes to negative, CH2, CO, CH3. Students, it contains two functional groups. It is ketone and it is alcohol. We call it ketone. Since aldehydes have similarity with ketones, it is again aldol condensation reaction. It undergo dehydration upon heating. I am sure concept is clear. Upon heating, alpha will lose H and beta will lose OH. There is double bond between alpha and beta. I write directly CH3 twice because 2 times around carbon, double bond CH. Alpha eliminates hydrogen and beta eliminates OH, bond formation. Rest is CO, CH3. That is alpha beta unsaturated carbonyl compound. Aldol condensation reaction do either in acetaldehyde or in acetone. Now students, we have to mention what is the product. It is clear, students. CH3 carbon participates, pi electron migrate to oxygen. It abstract alpha hydrogen from the adjacent second carbonyl compound. CH3C, CH3, it is inert part. It do not participate, remain as substituent. Carbonyl group participate, pi electron migrate to oxygen. It abstract alpha hydrogen from the other carbonyl compound. It means what will be left in second? CH2CO, CH3. Both are same ketone. Undergo dehydration, leads to a formation of double bond between alpha beta carbon. Dear students, that is a short trick to mention the product of aldol condensation. Please, it is aldol condensation. We proceed with dilute NaOH and then heat. What is the product of this reaction? You can directly write, students. Please look here. What is the product of this reaction? CH3C, CH3. You know it is bimolecular. What will happen? Eliminate oxygen from first carbonyl compound. Eliminate oxygen from first carbonyl compound and form its double bond with other carbonyl compound and eliminates 2 hydrogen from the other carbonyl compound. Upon heating, there is loss of water. Oxygen from first carbonyl compound and 2 alpha hydrogens from second carbonyl compound and form double bond between them. It is clear. First carbonyl compound loss oxygen. Now it will form double bond with second carbonyl compound but eliminate 2 hydrogen from it. When we eliminate 2 hydrogen from it, what is left? CH, CO, CH3. Dear students, please look here, that is formed. CH3 twice C, double bond CH, CO, CH3. That's the short trick how to mention product of aldol condensation reaction. You can directly write the product. dilute NaOH and heat, means CH3CH double bond CH-CHO. Please look here, CH3CH double bond CH-CHO. There's a short trick to mention product of aldol condensation reaction. Bimolecular eliminate oxygen from first and 2 alpha hydrogen from second and form double bond between these two, CH3CH double bond CH-CH. That's the chemistry of aldol condensation reaction. That's the essential condition, must have alpha hydrogen atom. After aldol condensation, dear students, second one is Cannizaro reaction. It is opposite to aldol condensation. It is given by the compounds having no alpha hydrogen. Carbonyl compounds containing no alpha hydrogen atom undergo self-oxidation and reduction. That is, it is disproportionation reaction. Carbonyl compounds having no alpha hydrogen atom undergo self-oxidation and reduction in the presence of concentrated alkali to give a mixture of alcohol and sodium salt of acid. Students, self-oxidation and reduction. Please look here. H2O2. It decomposes upon heating to give H2O and O2. It is disproportionation reaction. Same substance undergo oxidation as well as reduction. You know what is the oxidation number of oxygen in peroxide? -1. In waters, oxygen always have -2 except in peroxide. Elementary form 0. -1 changes to -2, that is reduction. -1 changes to 0, that is oxidation. Same substance undergo oxidation as well as reduction. We call such reactions as disproportionation reaction. And be careful, whenever it is competitive exam, which among the following reaction is also called disproportionation reaction, you always take Cannizaro reaction. It is opposite to aldol condensation, given by the carbonyl compound having no alpha hydrogen, just like formaldehyde, HCHO. Friends, there is no carbon atom is in direct link with function group, means it does not have alpha carbon. When it has no alpha carbon, means it doesn't have alpha hydrogen. Alpha hydrogen तो हो ही नहीं सकता जब alpha carbon ही नहीं है. Which compound give Cannizaro reaction? That is, which do not have alpha hydrogen, just like formaldehyde. Aldol, it was carried in the presence of dilute NaOH, but Cannizaro is opposite in the presence of concentrated NaOH. Again, dear students, it is bimolecular reaction. Twice of carbonyl compound having no alpha hydrogen are treated in the presence of concentrated NaOH. Please try to understand its chemistry again. HCHO plus HCHO. Bimolecular reaction. Whenever it is given, HCHO plus concentrated NaOH. Stoichiometry 2 will not be mentioned, but you know it is bimolecular. Now it is Cannizaro reaction. Carbonyl compound having no alpha hydrogen treated in the presence of concentrated alkali. Dear students, it is key point. You must know it is Cannizaro reaction is disproportionation reaction. That is, one will undergo oxidation and second will undergo reduction. Now how to mention the products? The carbonyl carbon which undergo oxidation will lose hydrogen, and the carbonyl compound which undergo reduction will gain hydrogen. The participation is of carbonyl carbon. Compound undergoing oxidation, carbonyl carbon will lose hydrogen. Compound undergoing reduction, carbonyl carbon will gain hydrogen. Now it is clear what is left. HCO. HCO plus, already there were 2 hydrogen around the carbonyl carbon. When it gain more, one more, that is number increased to 3, CH3O. Now students, these products are stabilized by alkali. The product of reduction will gain hydrogen from alkali. That is the product of reduction. It gain hydrogen from alkali. And product of oxidation will gain rest, that is O and A. Dear students, what happened? Carbonyl compound give acid and alcohol. Acid is higher functional group due to oxidation and alcohol is lower functional group, that is due to reduction. Again, Cannizaro reaction, carbonyl compounds containing no alpha hydrogen atom undergo self-oxidation and reduction in the presence of concentrated alkali to give a mixture of alcohol and sodium salt of acid. Whenever Cannizaro reaction, you say carbonyl compound having no alpha hydrogen are treated with concentrated alkali. That's enough. What happened? Again look here, it is Cannizaro reaction. One will lose hydrogen, because one undergo oxidation, and second undergo reduction. Second will gain hydrogen, already 2. When it gain one more, they becomes 3. The product of reduction will gain hydrogen from alkali, that is alcohol is formed. The product of oxidation will gain O and A, that is sodium salt of acid. It is Cannizaro reaction. Please try to complete in this reaction, but be careful, only carbonyl carbon will participate. That's assignment. Submit me on my this number 94595 76600. Dear students, carbonyl compound having no alpha hydrogen, it is treated with concentrated alkali. Definitely it is Cannizaro reaction. Carbonyl compound having alpha hydrogen treated with dilute NaOH, it is aldol condensation. Now there are two questions. Why formaldehyde does not undergo aldol condensation reaction? Simple, aldol starts from the letter A. Not given means due to absence of alpha hydrogen. Absence of alpha hydrogen again starts from the letter A. Any compound does not undergo aldol condensation. You will simply write due to absence of alpha hydrogen atoms. Please complete the answer. Again, why benzaldehyde does not undergo aldol condensation? What is the formula of benzaldehyde? C6H5CHO. C6H5CHO. Students, the carbon atom which is in link with functional group, we call it alpha carbon. Alpha carbon is already tetravalent. 1, 2, 3 sigma bonds and 1 pi bond is around it. It means it will not have alpha hydrogen. Any compound does not undergo aldol condensation. What is your answer? Due to the absence of alpha hydrogen atoms. Why acetaldehyde does not undergo Cannizaro reaction? Acetaldehyde does not undergo Cannizaro reaction. What is the formula of acetaldehyde? CH3CHO. What is the condition of Cannizaro reaction? Carbonyl compound do not have any alpha hydrogen. It means due to the presence of alpha hydrogen, it does not undergo Cannizaro reaction. Why formaldehyde does not undergo aldol condensation? Due to the absence of alpha hydrogen atoms. Any compound does not give aldol, your answer is absence of alpha hydrogen. Any compound does not give Cannizaros, your answer is presence of alpha hydrogen atoms. Attempt these questions. Suppose it is mentioned to you C6H5CHO. Dear students, it is again benzaldehyde. When we treat it with concentrated NaOH, it is Cannizaro reaction. Both are same. Self-oxidation and self-reduction. When it undergo oxidation, carbonyl carbon will lose hydrogen, and when it undergo reduction, carbonyl carbon will gain hydrogen. Please make products. Submit me. After this, next is Tissenko's reaction. Tissenko's reaction, that's the modified form of Cannizaro reaction. It means it is again disproportionation reaction, self-oxidation and self-reduction. All carbonyl compound undergo this reaction. May have alpha hydrogen or may not have, no matter in this reaction. Tissenko's reaction, at first you must know that is the modified form of Cannizaro reaction. If it is fill up, modified form of Cannizaro reaction is called, your answer is Tissenko's reaction. Tissenko's reaction, modified form of Cannizaro reaction, that is self-oxidation and self-reduction. It is the condition for Cannizaro reaction, that is, it is carried in the presence of aluminium ethoxide. Cannizaro reaction is carried in concentrated alkali. When it is mentioned in carbonyl compound, definitely it is Tissenko's reaction. Aluminium ethoxide act as oxidizing agent as well as reducing agent. Modified form of Cannizaro reaction. It is bimolecular, twice of this will participate. What will happen? Self-oxidation and self-reduction. When it undergo oxidation, it is clear it will form ethanol, it will form ethanoic acid. When it undergo reduction, ethanol will form ethanol, CH3CH2OH. It is oxidizing as well as reducing agent, supply nascent oxygen as well as nascent hydrogen. Complete the reaction. You must know aluminium ethoxide, Tissenko's, modified form of Cannizaro, self-oxidation and self-reduction. Oxidation CH3COH and reduction CH3CH2OH. Aldol condensation is given by the compounds having alpha hydrogen atom. Benzaldehyde does not give due to absence of alpha hydrogen atom. After this, next is reactions due to benzene ring. All of you know they are electrophilic substitution reaction. That is, hydrogen atom of ring is replaced by positive part of attacking result. First one is halogenation, second one is nitration, third one is sulfonation. Now you know it is deactivating group. When it is deactivating group, it is clear, that is the electrophile will attack at meta position. Please complete these reactions. In deactivating compounds, the electrophilic substitution takes place at meta position. Aldehyde and acids in your syllabus, these are meta directing. First one halogenation, second nitration, third sulfonation. After this there is two more reactions, Friedel-Crafts alkylation and Friedel-Crafts acylation. But clear, carbonyl compounds do not undergo these reactions. Carboxylic acids also do not undergo these reactions. मेटा डायरेक्टिंग कंपाउंड में हम फ्राइडल क्राफ्ट रिएक्शन कैरी आउट नहीं करते हैं. वाई कार्बोनाइल कंपाउंड डू नॉट अंडरगो फ्राइडल क्राफ्ट रिएक्शन? बिकॉज नंबर वन, carbonyl group is strongly deactivating group. We say when we do these reactions, electrophile will attack at meta. You have to complete these reactions. Means it is strongly deactivating group. Second, Friedel-Crafts reaction, catalyst is AlCl3. Catalyst AlCl3 gets bonded to carbonyl group strongly. Only these are the 2 points. Why carbonyl compounds do not undergo Friedel-Crafts reaction? If we proceed these reactions, yield is very less. Just like you know, C6H5CHO, CH3Cl in the presence of AlCl3. What we call it? Friedel-Crafts alkylation reaction. Electrophile will attack at meta position because CHO is deactivating group, meta position is alternate. But the yield of this product is very less. Output is less, it means we do not carry this. The reason is it is deactivating group, catalyst AlCl3 get bonded to CHO group strongly because it is Lewis acid electron deficient. After this, that's assignment for you. You have to complete all these reactions we have done in carbonyl compounds. It is clear, zinc amalgam concentrated HCl. It is complete reduction, Clemenson's reduction. Alkanes are formed. Acid chloride with H2 in PD plus BSO4. Rosenmann's reduction. CH3CHO dilute NaOH. Dear students, it is aldol condensation. Carbonyl compound having alpha hydrogen in dilute NaOH is only one reaction, that is aldol condensation. That is halogenation reaction. C6H5CHO, carbonyl compound having no alpha hydrogen in concentrated alkali, it is Cannizaro's reaction. Or it may be mentioned in this way. C6H5 means phenyl group. C6H5CHO concentrated NaOH, Cannizaro's reaction. Please complete these reactions and submit me soon. Thank you.